Now I want to do the second part of example E2.1, and in this case I have the same charges, but now I want to find the electric field at B due to these two charges. And so remember that I still have my the locations in vector form for Q1 and for Q2, but now I need the location for I need the location of B in vector form. So RB equals, and I can see that it has no x component, right? It's right on the y-axis, so that's going to be 0. And my RB is going to be this is just D. So that's my RB. So now if I want to find RB1, and that means I'm going to take I'm going to say RB, this minus this vector. And so what do I get? And I would expect to get something that looks like that. So I would expect my vector to look like that. So pointed in the positive x and the positive y direction. So let's see if that's what we get. So I'm going to take my RB, so 0, D0 is my RB, and I'm going to subtract my R1, which is a negative D over 2, 0, 0. And I get, now, so 0 minus a negative gives me a positive. I get D over 2, D, and 0. And is that what I would expect? It is, because if I notice the height here is D, whereas the length here is only D over 2. So I would expect to have a bigger number in my y value than in my x value. Okay, and so what about RB2? Again, here I'm going to expect to have a vector that's pointing this way. And so then I would expect to have a negative x but a positive y. So let's see if that's what I get. 0, D, 0 minus D over 2, D, 0. I'm sorry, 0, 0. This is 0. And so I get a negative D over 2, D, and 0. So I get a negative x and a positive y. So now if I want to find EB, that's going to equal EB due to 1 plus EB due to 2. And remember that the format that I'm using is the vector form over r cubed, where r is the length of the vector, and this is going to be r hat. Okay, so EB equals KQ over, and now what is the length of this vector, right? And I can look at it and figure it out, but I can also use my vector. My vector right here, RB1, and so what I'm looking for is the magnitude of RB1 is equal to RB1x squared plus RB1y squared. And so that's equal to square root of D over 2 squared, right there, plus D squared. And so that's equal to, so I have D squared over 4 plus D squared equals let's see, 5/4 times D. So the square root of 5/4 times D. Okay, so I write that in, 5/4 square root times D cubed. And I'm writing in my vector here, RB1, so that's going to be D over 2, D, 0. And now I'm going to add, now I'm going to do this term, so I have KQ over, and now this time it's going to be a negative, right, because this charge here is negative. And what am I going to have here for RB2? And it's the same. So I'm going to RB1 and RB2 the magnitudes, because these values are the same as these values, and I don't magnitude, this I'm going to be squaring this term, so I don't worry that it's a negative. So I get the same thing, 5/4 D square root and cubed. And now I'm going to have a negative d over 2, d and 0. So EB equals KQ and 5/4 square root d cubed. And now I can look inside and see what I have here. So I have d over 2, and I have a minus q here, a minus here. I pulled out the q, but I left the minus, and I have a minus here. So a minus and a minus is a plus, so I have plus d over 2. Now if I look here, I have d and then minus d, so I'm going to have a 0, right? I have the minus here. I've pulled out the q, so I have d and then minus d is 0. So that gives me EB equals KQ over 5/4 d cubed. Now d over 2 and d over 2, I'm going to pull a d out here, and so 1/2 plus 1/2 is just 1, 0, 0. So I can cancel one of these d's with one of these d's, so I'm going to end up with EB is equal to, and now 5/4, the square root of 5/4 cubed is, let's see, KQ over d squared, and I'm going to have 1 over, so 5 times the square root of 5 over 4 times the square root of 4. So I can flip that. 1, 0, 0. EB equals KQ over d squared times, let's see, I'll do 4 times the square root of 4 over 5 times the square root of 5 and times 1, 0, 0. Okay, so now let's see if that makes any sense. It tells me here that my electric field is only in the x direction. All right, so let's think about this. If I have, let's see if I draw it right over here. If I have two charges, positive and a negative, and here's my point B, the electric field at B due to this charge is going to be this way. The electric field at B due to this charge is going to be this way. Okay, so that makes sense, because if I were to add those two vectors, if I were to take this vector and then add that other vector to it, I end up with a horizontal vector here. So I find that this is correct. I do end up with the electric field at this point is going to point to the right, like that. That would be my EB.